Welcome back to Decentralized Application Development Crashcasts. I'm Sheila, and as always, I'm joined by my brilliant co-host, Victor. Before we dive in, I want to remind our amazing listeners that if you're enjoying our content, please take a moment to rate us on your podcast platform. Your support means the world to us.
Absolutely, Sheila. And hello, everyone. We're excited to continue our journey through Season 2, where we're exploring core hole-punch technologies. Today, we're diving into Chapter 3 on the Hypercore protocol, specifically focusing on understanding append-only logs.
That's right, Victor. And to kick things off, I've got a quiz question for our listeners. Are you ready?
I'm always ready for a good quiz, Sheila. Let's hear it.
All right, here goes. In which real-world scenario would an append-only log be most beneficial? A. A social media feed. B. A financial transaction ledger. Or C. A multiplayer game server.
Ooh, that's an intriguing question, Sheila. It really makes you think about the nature of append-only logs and their applications. Each of these scenarios has its own unique requirements for data management. I'm curious to see what our listeners will come up with.
Indeed, we'll reveal the answer at the end of the episode. Now, Victor, could you start by explaining what exactly an append-only log is?
Certainly, an append-only log is a data structure where new information can only be added to the end of the log. Think of it like a ledger where you can only add new entries at the bottom. You can't erase or modify previous entries.
That's interesting. So it's like a permanent record of events in order. But why is this concept important in distributed systems like Hypercore?
Great question. In distributed systems, append-only logs are crucial because they provide a consistent, ordered history of events or data changes. This is particularly important when you have multiple nodes or peers that need to stay in sync. The immutable nature of append-only logs makes it easier to maintain data integrity and resolve conflicts.
I see. So if I understand correctly, it's like everyone having an identical copy of a book, and we're all adding new pages to the end together.
That's a fantastic analogy, Sheila. Exactly right. And just like in your book analogy, if someone missed a few pages, they could easily catch up by requesting only the new pages they don't have.
That makes sense. Now, how does Hypercore implement this concept?
In Hypercore, append-only logs form the foundation of its data model. Each Hypercore feed is essentially an append-only log. When you add data to a Hypercore feed, it's appended to the end of the log and assigned a sequential index. This structure allows for efficient synchronization between peers and makes it easy to verify the integrity of the data.
Interesting. But I'm curious, how does this differ from traditional databases?
That's a great point of comparison, Sheila. Unlike traditional databases where you can update or delete records, append-only logs in Hypercore only allow additions. This immutability provides several advantages. It simplifies data synchronization, creates an automatic audit trail, and makes it easier to implement features like time travel and versioning.
I can see how that would be useful. But are there any drawbacks to this approach?
Absolutely, there are trade-offs. The main challenge is handling data that needs to be updated or deleted. In an append-only system, you can't just remove or change old data. Instead, you need to implement strategies like tombstones for deletions or additional entries for updates. This can lead to increased storage requirements over time.
That's a good point. It sounds like developers need to carefully consider their data model when using append-only logs. Are there any best practices for managing these challenges?
Definitely. One common practice is to implement compaction strategies, where you periodically create a new condensed version of the log that removes unnecessary old data. Another approach is to use a hybrid system where frequently changing data is stored separately from the append-only log.
That makes sense. Now, I'm curious about a potential edge case. What happens if two peers try to append data simultaneously? How does Hypercore handle that?
Excellent question. Hypercore uses a single writer model, meaning only one peer, the original creator of the feed, can append data. Other peers can read and replicate the data, but they can't directly modify it. This approach sidesteps many of the complexities associated with distributed write conflicts.
I see. That's a clever way to maintain consistency. Before we wrap up, is there a fun fact about append-only logs you'd like to share?
Sure, here's an interesting tidbit. The concept of append-only logs isn't just used in modern distributed systems. It's actually an ancient idea that dates back to bookkeeping practices in medieval times. Merchants would keep ledgers where they could only add new entries, never erasing old ones, to maintain a trustworthy record of transactions.
That's fascinating. It's amazing how some concepts stand the test of time. Now let's reveal the answer to our quiz question. Victor, would you like to do the honours?
Of course. The answer to our quiz question is B, a financial transaction ledger. While append-only logs can be useful in various scenarios, they're particularly well-suited for financial records where maintaining an immutable history of all transactions is crucial for auditing and compliance purposes.
Thank you, Victor. To summarise today's episode, we learned that append-only logs are data structures where new information is only added to the end, providing an immutable, ordered history of events. They're crucial in distributed systems like Hypercore for maintaining data integrity and efficient synchronization. While they offer advantages like simplified versioning and auditing, they also present challenges in handling updates and deletions, which can be addressed through strategies like compaction.
Excellent summary, Sheila. And remember, listeners, if you found this episode helpful, please visit crashcasts.com and consider joining our Discord community. Your support on Patreon helps us continue creating this content, and don't forget to subscribe and rate the podcast on your favorite platform.
Absolutely. Thank you all for listening, and we'll see you in the next episode where we'll dive deeper into the Hypercore protocol. Until then, happy coding.